Okay, sorry I had to interrupt before. So we're moving on to question number 4. They are going to show it up with different numbers for you, but essentially in this question here, they have 4 cosine theta minus 3 sine theta, that binomial squared, plus 3 cosine theta plus 4 sine theta squared equals 25. So because the binomials are squared, I'm going to FOIL both, and I'm going to say 4 cosine theta minus 3 sine theta times 4 cosine theta minus 3 sine theta. And remember, you must FOIL. When you FOIL this, you get 16 cosine theta cosine squared theta. And then minus 12 sine theta minus 12 sine theta plus 9 sine squared theta. And you do the same thing to the other expression. And when you FOIL that other expression, which is 3 cosine theta plus 4 sine theta, so 3 cosine theta plus 4 sine theta times itself, 3 cosine theta plus 4 sine theta. Then you have to FOIL again. Okay? Once you FOIL, you're going to get 9 cosine squared theta plus 12 sine theta cosine theta. So 12 cosine theta sine theta plus 12 sine theta cosine theta plus 16 cosine squared theta. Sorry, sine squared theta. So essentially, I'm just FOILing. There's nothing new here. So 16 sine squared theta. So over here, now I can combine like terms. So I really should have more room for this. But I have, from the top expression, I have 16 cosine squared theta. You know what? I'm going to get a blank page here because I don't have enough room. It's best to do this on a piece of paper. I always have a blank piece of paper and a pencil. Very old-fashioned. So here we are, new blank page. I am just going to say, pick up where I left off, which was here. I had this one, which was 16. So I can combine the negative 12 sine theta minus 12 sine theta, which gives me negative 24 sine theta cosine theta. I forgot the cosine theta. Cosine theta. So now I have 16 cosine squared theta. 16 cosine squared theta minus 24 cosine theta sine theta. And then the last one was plus 9 sine squared theta. Plus 9 sine squared theta. So I am going to take the second expression. I'm supposed to add that. I'm going to do that vertically because I don't have a lot of room. So I'm going to go ahead and add this over here. And I'm going to say 9 cosine squared theta plus 24 sine theta cosine theta plus 16 sine squared theta. So 9 cosine squared theta. So plus 9 cosine squared theta plus 24 cosine theta sine theta plus 16 sine squared theta. And when you do that, once again, I'm just FOILing everything. This cancel out, and I'm left, these two are like terms. They both have cosine squared theta, so it's 25 cosine squared theta plus 25 sine squared theta. And that should have been the first part of this part. They say do not factor. Let's see, verify. Okay, so that it should be equal to, okay, this one they don't want you to factor, so over here in this box, you should have written this over here. And then you can factor out, which will show that you verified the identity. Okay? All right. So for this one, essentially just write the two binomials, FOIL, combine like terms, and then at the end you can factor out the 25. Okay? All right. Verify the identity, secant squared x plus tangent squared x equals 1 plus 2 tangent squared x. Well, we need to use one of the Pythagorean identities. I know that secant squared x should be, here, I'll show you. Pythagorean identities. So if you look over here, you have there 1 plus tangent squared x equals secant squared x. So 1 plus tangent squared x, this is 1 plus tangent squared x. 1 plus tan squared x plus tan squared x, which will give you 1 plus 2 tan squared x. They're like terms, so you can combine. So this is what you have here. You have 1 minus tan squared x plus tan squared x. No. 1 plus tan squared x plus tan squared x, which is going to give you 1 plus 2. There you go. All right. I believe. 1 plus 2 tan squared x. Yeah. Yeah. Okay. And so that takes care of that. This one, you have to prove. Well, they broke it up in steps. Secant squared x minus tangent squared x, that's also an identity. Usually it's a Pythagorean identity. So that's just going to be 1. And then once you do that, sine squared x plus cosine squared x is also a Pythagorean identity. That is 1. That equals 1. So it's not as bad as you think. And for this one, they are manipulating. Let me see how many more. Okay, not too many. Okay, 2 more. So this one, they want you to choose the sequence of steps that you take. They want you to show that the 1 plus cosine t over sine t is the same as sine t over 1 minus cosine t. So they are started with the left-hand side, and they wanted to make it look like the right-hand side. Okay, so 1 plus cosine t, I can multiply by the conjugate. That's one of the strategies you can use. I'm looking, so this one, okay, so let's look at one by one. This one would not work because if I FOIL this, I will not get this, because for me to get 1 minus cosine squared t, one would have to be a positive, the other a negative. If I FOIL 1 plus cosine t times 1 plus cosine t, I am going to get 1 plus 2 cosine t plus cosine squared t, which doesn't work. So it's not A. I'm going to go on and look at choice B. If I, once again, B is not going to work because 1 plus cosine t times 1 plus cosine t should be 1 plus 2 cosine t plus cosine squared t. Doesn't work. Letter C, if I multiply by the conjugate, then this one over here should be a minus, not a plus. So it's not that one. I'm only left with letter D, and that should be my correct answer. when I multiply by the conjugate, this 2, I get 1 minus cosine squared t, and that's what I want, over sine t times 1 minus cosine t. This equals, it's a Pythagorean identity, sine squared t, and then on the bottom stays the same, and then you can just cross this out, and you proved your identity. Very good. And last but not least, secant theta over 1 plus sine theta equals 1 minus sine theta, of course, sine cubed theta. So they started once again with the left-hand side. They want to make it look like the right-hand side. So what did they do here? Well, they apparently found, they multiplied by cosine theta. So let me take a look at the other options. For letter B, they multiplied by the conjugate of 1 plus sine theta. For the third one, they multiplied by 1 plus sine theta. So let me look at each of the steps and then decide. So this will give me, secant, this should not be cosine squared theta. Well, cosine theta is not 1 minus sine theta, so I can eliminate that right away. It's not going to be this. Cosine theta is not 1 minus sine theta. Cosine square theta is 1 minus sine square theta. So let's take a look at the next one. So for this one, they multiplied by 1 minus sine theta, which gives me in the denominator 1 minus sine square theta. That is correct. Let's see, secant theta times 1 minus sine theta would be, so they are saying that secant theta minus secant theta sine theta is 1. I'm not sure where that is coming from. Let me check letter C. So this one, they're multiplying by 1 plus sine theta. I'll go back. I'm not sure about letter B yet. There's no D? Okay. So the letter C, they multiplied by 1 plus sine theta, secant theta, and this is already wrong, so I can eliminate it. 1 plus sine theta times 1 plus sine theta would be 1 plus 2 sine theta plus sine squared theta. That does not work. So it must be this one. So I'm going to go back and take a closer look. And let's see, secant theta over 1 plus sine theta. Okay. So let's see over here. Secant theta minus secant theta sine theta. And okay. Is this B? No, that's C. Never mind. Secant theta 1 minus sine theta. Oh, I see what they did. Okay, so secant is 1 over cosine. Okay, so they took, now I understand. They took secant theta and they wrote it as 1 over cosine theta. And now they got 1 minus sine theta over cosine cubed theta. So that definitely works. That should be my answer. Okay, I hope that helps a little bit. You can go back, see how you do these assignments, reach out if you have any questions. Thank you.